For this video, I'd like to talk about two-step equations. So these are equations where we're going to be solving for some variable. In this particular case, we're solving for x. And in general, it will take 2 steps to solve these equations. So recall from the last videos on one-step equations that you want to think in terms of opposites or opposite operations. So we know our goal in all of these problems, it's going to be the same. We just want to get our variable equal to some number. And my advice is always to first interpret this using English, using words to try and better get an intuition for what's going on. So when you see a problem like this, you want to think of it as 2 times some number plus 5 gives you 11. So what could that number possibly be? And you can go through and start guessing whole numbers, like 2 times 1 is 2, plus 5 gives you 7. So it's not 1. You can try 3. 2 times 3 is 6, plus 5 gives you 11. So you can guess your way to figuring out that x is equal to 3. But a lot of these problems do end up having decimals or fractions as the answer, and it's very hard to guess your way to the answer. So we need a step-by-step mathematical process of actually solving these equations. And to do that, well, let's take a closer look at the equation. So we have 2 times x, and we have plus 5. We know we want to get x by itself on one side of the equation. But to do that, we first got to get rid of either the plus 5 or the multiplication by 2, right? Because we have to cancel both of these out to get x by itself. And the question is, which one do you do first? Do you cancel out the multiplication by 2, or do you cancel out the addition and subtraction first? And my general advice is to get rid of the simpler operations first. So get rid of the plus and minus first, if you have minus, and then get rid of multiplying and dividing. And the reason for that is that if you try and get rid of multiplication early on, you might end up creating a much more difficult problem for yourself. For instance, let's try and get rid of this times 2. And we want to do the opposite, so we will divide by 2 to cancel that. But the problem is, if you divide something by 2, you have to divide everything by 2. All right, same thing with multiplying. If you multiply something by 2, you have to multiply everything by 2. So this gets divided by 2, and this gets divided by 2. And so you end up with these canceling out. You get x plus 5 halves equals 11 halves. And this is solvable. You can subtract 5 halves from each side, and you would still get 3. It would simplify to 6 over 2, which does reduce to 3. However, you essentially created a more difficult problem for yourself, because now you have to deal with adding and subtracting fractions. This route is definitely viable. You can do it this way, but my philosophy is, why make life harder when you can do things a simpler way? So instead of dealing with the multiplication and division first, I want to deal with the simpler operations first. I want to deal with the addition. So how do I cancel out addition? Well, I can subtract, and I'll just subtract 5 from each side. When dealing with addition and subtraction, you just have to subtract or add the same amount to both sides. It's only when you're multiplying or dividing that you have to multiply everything by that number. And it's effectively because if I multiply by 2 on this side, I really have to distribute it to everything. All right, but we'll talk more about that later. For now, I'm just subtracting 5 on each side of the equation because plus 5 minus 5 is just 0. So I get that 2 times x equals 6. And now that I've isolated this x term and I've gotten rid of the simpler operation first, now I can use division to cancel out multiplication. Since I know that 2 divided by 2 is just 1, and so I just get 1x, or x, equals 6 over 2, and 6 divided by 2 is 3. So you can see that by dealing with the simpler operations first, it made the problem a little bit easier to handle. You didn't have to deal with any adding or subtracting fractions. Now, if you don't mind going that route, feel free to do it whatever way you want. But my advice is to take the simplest path. So let's do another problem. Let's say we have 7x minus 4 equals 12. And like the last problem, we could start by dividing everything by 12 or by 7. Right? We could do this, but then we might get x without anything multiplied by it, but then we're going to have to deal with adding and subtracting fractions. So let's avoid that unless you really want to do that. So I'm going to get rid of the minus 4 first, because we know our goal is to get x equals something. And so we got to get x alone on one side of the equation. And right now it's got this minus 4 attached to it. So I'm going to add 4 to each side, since I know that minus 4 plus 4 would just give me 0. They are opposites, they cancel each other out, and you get 0. So 7x is 16. And now I can get rid of this multiplication by using division. I'll divide each side by 7. 7 divided by 7, I know it's just 1. So these cancel, and I get that x is 16 divided by 7. Now, this fraction does not simplify. 7 does not go into 16 evenly, and they don't have any common divisors. No whole number divides evenly into both of these besides the number 1. So we can't simplify this, so this is our final answer. And at this point, you want to check your work, just like you would do with any simpler equation. And we're going to check it by plugging it back in to the original equation. So we'll plug in x equals 16 over 7, where we see an x. So you get 7 times 16 over 7 minus 4. And the question is, does this equal 12? And for this first part here, we're multiplying fractions. But effectively, we have 7 in the top and 7 in the bottom, so they're going to cancel each other out. The 7s cancel, and you just get 16. Now, if you want to actually multiply this out, you can do that. 7 times 16 would be 70 plus 42, be 112, and then dividing by 7, you would get back to 16. But whenever you're multiplying fractions and you have the same number in the numerator and the denominator, they always just cancel, because 7 divided by 7 is just 1. And then take away 4 from that, and we do get 12, which means that we can feel very confident that x equals 16 over 7, that this is, in fact, the right answer.